All right, this is the moment we've all been waiting for. This is your first math lesson of the year in Honors Pre-Calc. I will fully admit that this is probably a review. This is probably too easy for you, and probably most of you already know how to navigate this really well. But it's important to make sure that we're all on the same page to start. This lesson is on function notation, which is how we now, as advanced mathematicians, are going to talk about coordinates on the plane almost always. So we won't use x and y together too often anymore. We will use f of x and x together now. And you've seen this before in algebra too. So what this looks like, what I'm talking about, is something like f of x. And just note how you say that is how it's said, f of x. If you're somewhere where it wouldn't be weird to do so, you can even say it out loud, f of x. And what this means, right, is that there's some quantity f that depends on the quantity of x. Okay, so in other words, it describes a relationship. And again, this is not rocket science. This is something you've already seen before. But let's look at some particular relationship here and just make sure we can kind of translate this notation into both like the context and into that like x comma y notation that we're more familiar with. So this particular problem, make sure you've read it. I'm not going to read it to you because I trust that you can do that. Pause the video if you haven't read it already and read it now. What it's doing is relating f of x to x, where f of x is how much gas you have left after driving x miles. So x is the number of miles you've driven. And this is like fully inspired by the fact that my gas gauge is very low in my car. My gas light is on as we speak. So we all have seen this before, right? Even if we're not driving quite yet. Like obviously as you drive, that gas gauge gets lower and lower. So we can sketch this relationship. It's a good idea to label your axes both with their names, f of x and x, and also what they are. So this is miles on the bottom here, and this is gallons left on this side. And we don't know a whole lot about f of x, but we do know it should be decreasing. So I'm just going to draw a decreasing linear function here. And that could be a potential graph of f of x. And then I like to annotate as I read these context. Maybe some of you have already done this. So I would annotate the amount of gas left and x miles. And just make a note of what we're talking about so that we can start to fill this out. So x was the number of miles driven. F of x was how much gas you have left. We'll say gallons. Good to have units, right? Gallons of gas remaining. Okay, so that was not rocket science, right? Now, though, we have statements, right? So the way we read this is f of 120 is equal to 2. Again, you can read that out loud if you're in a place where it wouldn't be weird to do so. And this is like a more interesting question, right, than just like what is x, what is f of x. This is a whole statement that we have to translate. Now, if I'm looking at this, what I'm thinking, right, is that usually there's an x inside that f, right? So 120 is an x value. There we go. And that means 2 must be a y value, right? Or 2 is a value of f. So what this means in like normal human language is that if x is a number of miles, it means that after 120 miles, you have 2 gallons remaining. And this could also be a point on our graph, right? And remember, this is just a sketch, so I can just kind of make it wherever I want. So let's say this is my point that corresponds to this statement. That would be the point 120, 2 gallons, right? So y value of 2, x value of 120. And then we have a couple of other points that we're going to look at. So we have f of 0. So this means my x is 0 is what this is saying. So this would be, f of 0 would be how much gas remaining after 0 miles. You already have a word for this. It would correspond to this point on your graph, right? And that word is your y-intercept. And then f of x equals 0, that's kind of the opposite situation, right? So this is really saying that this is my y equal to 0, right? So that would be this point down here. And In context, well, this is like the worst point to be at. This is where I'm almost at, is like when you run out of gas. So it's like the number of miles at which you run out of gas. And of course, this is the y-intercept. Okay. So hopefully none of this seems like brand new to you. We'll annotate that point on the graph as well. Okay. So this is important to be able to translate this notation, because this is how we make meaning out of it, right? Otherwise, it's just a bunch of numbers and symbols, but it's good to be able to apply it to a context. This is a great time to just like stop and reflect and make sure your notes are complete and make sure that you understand everything that you've written down. I know my handwriting is not the best and it's early in the year, so maybe you have not learned how to read it yet, so let me know if you have any questions about your notes as well. We're going to move on and consider just a couple of other situations with this notation. The first is just like whether my graph over here could be a function, right? So could this be a graph of f of x, and then we explain why or why not. And the answer here is no. And this is the vertical line test, right? So you guys know that, if I can draw a straight line through 2 points on my graph vertically like that, it's not a function. Which is great if you remember the vertical line test, but it's even better if we can relate it to this idea of driving and gas, right? So in this context, let's think about what this would mean. So this would mean that at a certain number of miles, we have two different amounts of gas left, which is just nonsense, right? So that's kind of why we consider these things not a function, because it doesn't make sense. It's not a good map, right? So each x value has to have exactly one y value. So we can annotate here that this is the vertical line test we're failing here. Okay. Last couple things regarding this notation is just a couple of things you're going to need for your homework that goes with these notes. The first is just this notation and how it relates to points. I see students, even my AP Calc students, mess this up sometimes. So g of 0 equals 2. That means the point 0, 2, right? So remember that inside one is an x value. So what it is not is the point 2, 0. That's backwards. So the point 0, 2 on my graph is that point right here. So that's the point corresponding with that equation. And then f of 2, just so you know how to operate this algebraically, f of 2 is equal to 2 times 2 minus 3. That for sure you all know how to do. So that spits out, what does that spit out? 1, right? So we'd say f of 2 is equal to 1. And then find an x such that f of x equals 12. This sounds harder, but it's just like if I said like y equals 12. It means the same thing. So you'd be like, okay, 12 equals 2x minus 3. And then you would solve from there. And I think this gives you, what? 7.5. And you guys know how to do that. I'm not going to show you the intermediate steps.